Geometric proof. Our objectives are to write two-column proofs as well as prove geometric theorems by using deductive reasoning. Who uses this? To persuade your parents to increase your allowance, your argument must be presented logically and precisely. So, you use it. Alright, let's look at the flow of a proof. You start with your hypothesis, then you use definitions, postulates, properties, and theorems to kind of justify your hypothesis to make your conclusion. Alright, so when writing a proof, it is important to justify each logical step with a reason. You can use symbols and abbreviations, but they must be clear. You want everyone to know what you're talking about. So let's practice making justifications. Write a justification for each step, given that angle A and angle B are complementary, and angle A is congruent to angle C. So let's look at this first one here. Angle A and angle B are complementary. Why are you allowed to say that? You're allowed to say it because it's a given piece of information. They gave it to you. Okay, this next one gets a little bit harder. The measure of angle A plus the measure of angle B equals 90. Why are you allowed to state this? Using your information from number 1, what enabled you to say that the measure of angle A plus the measure of angle B in fact equals 90? Well, the definition of complementary angles states that. These two angles, if you add them together, they have to equal 90. Okay, well now we're suddenly going to, alright, well angle A is congruent to angle C. What enabled you to say that? If it doesn't follow from something previous, chances are it might be in the given information. So look back up here. Yes, in fact it is. They gave it to you, so that's why you are allowed to state that. Alright, well using that angle A is congruent to angle C, we're jumping to the measure of angle A equals the measure of angle C. Notice the only thing different here is this one is talking about your angles, the figure of your angle being congruent, and this is talking about their measures being equal. Whenever you change from congruent to equal or equal to congruent, and that's really the only thing that's changing, you're using the definition of congruent angles. If you were talking about segments, it would be the definition of congruent segments. Okay, well now let's look at 5. We have the measure of angle C plus the measure of angle B equals 90. Okay, so this looks very similar to number 2. The only difference is the measure of angle A is suddenly now the measure of angle C. Well, we were allowed to switch them out because the measure of angle A equals the measure of angle C. So we substituted C in for A. So therefore the substitution property of equality. And last but not least, angle C and angle B are complementary. Well, this is very similar to your 1 to 2 as in your 5 to 6 here. So you're saying that, okay, well it's complementary, so that means if you add them together you get 90. Alright, well if you add them together and you get 90, that means, hey, the two angles are complementary. So you use the same line of reasoning. You use the fact that the definition of complementary angles means that they have to be 90 degrees. A theorem is any statement you can prove. Once you have proven a theorem, you can use it as a reason in later proofs. So the linear pair theorem. If two angles form a linear pair, then they are supplementary. So your hypothesis, if angle A and angle B form a linear pair, then angle A and angle B are supplementary. Let's look at another theorem, the congruent supplements theorem. If two angles are supplementary to the same angle, then the two angles are congruent. So if angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary, that means angle 1 and angle 3 have to be congruent. Let's try a couple proofs. Fill in the blanks to complete a two-column proof of the linear pair theorem. So given, angle 1 and angle 2 form a linear pair. We want to prove that angle 1 and angle 2 are in fact supplementary. Alright, so we start with our given, and we use our given information to make our next statement. So, if angle 1 and angle 2 form a linear pair, then ray BA and ray BC must form a line, because that's the definition of what a linear pair is. Alright, well that means the measure of angle ABC equals 180 degrees. Well, why are you allowed to state that? Oh, well, definition of straight angles allows you to state that. Alright, here comes our first blank. The hint they gave us is the angle addition postulate. So, the angle addition postulate is when you take one piece of an angle plus another piece of an angle and you get your total angle. So we have the measure of angle 1 plus the measure of angle 2 must equal the measure of angle ABC. Well, we're getting closer. Now we must use some substitution. Look at steps 3 and 4. Is there anything you can substitute out of 4 and replace it with something else? Well, the measure of ABC is equal to 180. So we can substitute the measure of angle ABC for 180 degrees. So we have the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Alright, so now we have angle 1 and angle 2 are supplementary. What is the line of reasoning for why we are allowed to state that? Well, angle 1 and angle 2, if you add them together, give you 180. Well, that means one and 2 have to be supplementary. So the definition of supplementary angles. Let's look at this next one. Fill in the blanks to complete the two-column proof. Alright, so we have angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary. Prove that angle 1 and angle 3 are congruent. Alright, so we always start with our given information. So we've got angle 1 and angle 2 are supplementary. Let's try spelling that right. S-U-P-P, supplementary. And angle 2 and angle 3 are supplementary. Alright, so based on the definition of supplementary angles, that means if you were to add 1 and 2 together and 2 and 3 together, you would get 180 degrees. Well, we need to simplify this up a little bit. So we're going to use substitution. Is there anything that you can substitute in 2 to be able to simplify this? Well, 180 and 180, they're the same. So that means you can set angle 1 and angle 2 equal to angle 2 and angle 3. So we have the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. Okay, so now we need to simplify that one step further. We have the measure of angle 2 equals the measure of angle 2. I know it might sound a little ridiculous, but it's important to have it there. Now you can use the subtraction property, and you can subtract that measure of angle 2 from both sides. So the subtraction property of equality. And then the last statement is always what you're trying to prove. And you use the definition of congruent angles to get you there. Two more theorems. The right angle congruence theorem states that all right angles are congruent. And the congruent complements theorem, very similar to the congruent supplements theorem, if two angles are complementary to the same angle, then the two angles are congruent. Alright, writing a two-column proof from a plan. Use the given plan to write a two-column proof of the right angle congruence theorem. So try this on your own. Use this plan and try to come up with a two-column proof. The answer will be revealed once you come back to the video. So our statements and our reasons. We start with our given, so angle 1 and angle 2 are right angles. And then from there we go to step 2. Because of the definition of right angles, we're allowed to say that the measure of angle 1 equals 90 and the measure of angle 2 equals 90. Now we can use the transitive property of equality to make the statement that the measure of angle 1 has to equal the measure of angle 2. And we end with stating that the angle 1 is congruent to angle 2 because if their measures are equal, then their figures are congruent by the definition of congruent angles. This may help. The proof process. Step 1. Write the conjecture to be proven. Step 2. Draw a diagram to represent the hypothesis of the conjecture. Step 3. State the given information and mark it on the diagram. Step 4. State the conclusion of the conjecture in terms of the diagram. Step 5. Plan your argument and prove the conjecture. Well, folks, that concludes our lesson on geometric proof.